Welcome to Ramya Teacher's Classroom. I am absolutely thrilled to have you joining me today. We're going to explore one of the most fascinating and honestly fundamentally important processes on our entire planet. Have you ever looked at a bright green leaf and just wondered what exactly makes that color so special? Well, today we aren't just going to talk about it, we're actually going to scientifically demonstrate it. In this explainer, we're walking through a classic scientific experiment to prove exactly why chlorophyll, that magical green pigment, is absolutely essential for a plant's survival and ultimately for ours. So, here is our game plan for today. We're going to move logically through the scientific method. We'll start with the experiment aim, gather our apparatus and setup, walk through the step-by-step procedure, review some really important safety precautions, and finally get to our observations and conclusion. All right, part 1. The experiment aim. Every great scientific journey begins with a clear question, or, a mystery that needs solving. And for us, that mystery lies in the green leaves all around us. Our primary aim here is to prove that chlorophyll is necessary for photosynthesis. We already know that plants make their own food using sunlight, right? But our hypothesis today is that the green pigment itself is a completely non-negotiable part of that recipe. We're going to systematically and scientifically demonstrate the vital role this pigment actually plays. Moving right along to part 2, apparatus and setup. Now, the absolute core component of our setup is the variegated leaf. If you're not familiar, a variegated leaf comes from a healthy plant. Think of something like a croton or a coleus, and it has clear, distinct green and non-green regions right there on the exact same leaf. This specific type of leaf is the linchpin of our entire experiment. Why? Because it gives us a built-in natural comparison between areas that contain chlorophyll, the green parts, and areas that do not, the non-green parts. We really need this direct contrast to prove our point. Okay, let's dive into the rest of our checklist. Alongside our variegated plant, we're going to need a beaker and water, a test tube and alcohol, and a hot water bath. We'll also need forceps for safe handling, iodine solution, which is going to be our key testing agent later on, and a plain white tile so we can clearly see our results. Once we've got all these items neatly arranged on our lab bench, we're ready to rock. That brings us to part 3, the step-by-step procedure. First things first, we take our healthy variegated plant and keep it in direct sunlight for about 3 to 4 hours. This is just to ensure the plant is actively photosynthesizing. Then, we pluck one of those beautiful variegated leaves. Step 2, we boil that leaf in water for about 2 minutes. Now, step 3 is crucial. We transfer the leaf into a test tube containing alcohol, and we heat it in our hot water bath until the leaf becomes completely colorless. What we're doing here is essentially stripping the leaf of its green chlorophyll so it won't mask our test results later. Finally, for step 4, we gently wash the now colorless leaf with warm water, place it nice and flat on our white tile, and add a few drops of our iodine solution all over it. Before we look at the results, part 4, important safety precautions. Now, to get accurate results, you have to ensure the leaf has those really clear green and non-green regions, and the plant absolutely must be in the sunlight before starting. If it's been in the dark, no photosynthesis will have happened at all, and the whole thing's a bust. You also need to handle the fragile, boiled leaf very carefully with your forceps and make sure to add your iodine uniformly. But take a look at that final point. This is absolutely critical. You must heat the alcohol only in a hot water bath, never ever directly on a flame. Alcohol is highly flammable, it's a severe fire hazard, which is exactly why the hot water bath from our apparatus list is 100% mandatory for this procedure. All right, the moment of truth, part 5, observations and conclusion. It's time for the big reveal. When we add the iodine, the visual contrast is just striking. The portions of the leaf that were originally green turn this deep, dark, blue-black color almost immediately. However, the portions of the leaf that were originally non-green, they simply stay the brown or yellow color of the iodine itself. So, what does this sudden color change actually mean for us? Well, in scientific testing, a blue-black reaction with iodine is the universal indicator for the presence of starch. Therefore, our result is loud and clear. Starch is formed only in the parts of the variegated leaf that were originally green. The plant was only able to produce and store its food, the starch, in the specific areas where that green pigment used to be. And that brings us to our final, undeniable conclusion. Chlorophyll is necessary for photosynthesis. Only the green parts containing chlorophyll can prepare food in the presence of sunlight. We've literally proven it right here in the classroom together. As we wrap up today's explainer, I want you to think about this. If a single, totally invisible chemical reaction inside a tiny leaf is the engine that sustains all life on Earth, What other microscopic miracles are happening right under our noses every single day? Keep questioning the wonderful world around you, and I'll catch you next time.